I wrote this program already, and it's kind of a long one, but let's talk through it really quickly, just so we know what's happening. And you should always do this when you're writing code. Try to read through it. If you look at somebody else's, read through it for a minute. Don't just run it and say, I hope it works well. Try to figure out what's happening. So I haven't put official comments in. We're discussing it together. So what I have here is I have 3 LEDs, constants, because I'm not changing them throughout the program, throughout the sketch. Bytes, because that's the smallest data type that'll work, named LED R, G, B, and Y. I also have a constant byte for pin 5. I'm going to end up using that for my potentiometer. In the setup, I start a serial monitor. I always do this if I'm prototyping something. I sometimes don't end up printing something, but most of the time I will, so it's nice if it's already there. I also added pin modes for my 4 LEDs. I didn't add one for my analog because analogs don't need pin modes. So the first thing I'm going to do in my loop is I'm going to get a value from my analog pin. And I'm going to save it in this called value. I'm going to print that so that if I need to take a look, I can take a look to see if it's working, to see what the values are. Then I have just a bunch of if statements. I have if the value is less than 200, turn this red one on, turn the rest off. And I start getting into some of this more complex logic. If it is greater than or equal to 200 and less than 400, turn the green one on, everything else off. If it's between 400 and 599, right, just less than 600, the blue one's going to be on, the rest will be off. Between 600 and 799, the yellow one is on. Between 800 and 999, they're all off. If it's between 1000 and 1022, they're all on. And if it's at the very maximum at 123, right, if it equals 123, I'm going to turn them all on, wait, turn them off, and wait will end up blinking. So it's a longer code. It's 88 lines officially. I do have some spaces in here. I space things out to be a little bit more organized. But let's go ahead and run it and make sure that it works. So I'm going to start the simulation. We'll open the serial monitor to see what's happening. And let's just start it off at 0. So 0, the red one's on while I'm less than 200. And as I keep moving, we'll see that the green one eventually turns on, the blue one turns on, the yellow one turns on. They all turn off. Oh, I went a little too far. I made kind of a small window here for the all on. So all on, I'm over 1,000, but I'm less than the maximum. If I go to the maximum, it flashes. All right, so, and we can see that. First I turn on the red, then I turn on the green, then the blue, then the yellow, then all off, then all on, then we blink. So we know that it works. You'll see that it's an alright code. If statements are perfectly fine here. The way that I wrote it, it does work the way that I want. If I go back down, things change back. But I did have to put this complex logic in and think a little bit harder about what needs to go into it. So what I want to do is I have rewritten it using else ifs and elses as well. We've discussed them in class a little bit. Let me stop the simulation. I'm going to go ahead and delete this one. And if you're watching this before we cover it in class, I'll talk about it a little bit as we go through. So I saved my code here of using it in my else's. So first off, if I say else or else if, what it's doing is it's dependent on something previous. So that means that I always have to have a starting if statement. That's always required anytime I want to use an else or an else if. I have to have a starting if statement. It's going to look like any other if that you have done. But what's going to happen is instead of this just being an if, because if this was an if here, what would happen is this could run when it's under 200, my red one's on, but when I get between 200 and 400, my green one will turn on, but this one's also true, so it'll turn on the red one, but then it'll turn the red one right back off, and it might do some weird stuff. I'm not going to be able to see maybe with the simulation. It looks like maybe this one's are kind of dim, the red one's dim, because of the way that I've written it. And also the green one is on even when I'm at 0. So it's doing some weird things. And the reason for that is my logic isn't very good. And so sometimes you have to write really good logic, but your logic statements can get really convoluted and really, really long and difficult. So if all I do is if I order things correctly and make some of them else ifs, and else if still needs a condition, but this scope of the else if, what it does is it will only run if the if statement that is directly above it is false. So if this if statement is true, every single else if or else that is directly underneath it will not run. And by directly underneath it, I include this else if, this else if, this else if, this else if, and this else. They're all directly underneath it because there's no other code doing anything else. And so they look back, the whole point here is if I have this else, it looks back and it says, what else ifs and elses, what else ifs and ifs am I tied to? And it checks to see if any of those have been true along the way. If this is true, every single one of those else ifs and elses gets skipped. The condition doesn't even get checked. There's no point. Because this was my number one priority, and it was true, which means the other ones don't work. Now, if this one's false, we check this second condition. If that one's true, this will run. And since this ran, every single else if and else after this will not run, even if that condition might be true, because the else if will not run if something preceding it was true. So if this is false and this is true, this will run, but nothing below it will. Lastly, when we finally get to the else, you'll notice the else doesn't have a condition. There's no value. There's nothing to check in the else, and that's because it's default. If everything above it was false, this will run no matter what. That way, if I might have a very, very difficult condition that I can't figure out how to exactly write, or it's just got too many options, just have it be the default. If anything else might possibly happen, go ahead and do this. So let's go ahead and run this, and it should run the same way as the previous one. Red one's on, and when I get to about 200, it should turn off. The green one turns on. And when I get to 400, it should turn off in the blue one, then the yellow, then they'll all go off. Then when I get to 1,000, they all turn on. And when I get to anything else, and in this case anything else is anything that's not between 0 and 1022. So that means when I max out at 1023, it's going to flash. So that's one way to use else-if statements. It can help you just simplify your code. You'll have to organize it well, and again, since this is a design class, this is a great method of doing things. You'll have to outline it, make sure you have things with the proper priority, come up with anything that you need, place it in there. It also optimizes code. If it doesn't have to check every single if to see if it's true, then it's going to run a little faster, it's going to run a little bit more efficiently, because even when I had my past code in here, let's see, here we go. Even if this one was true and the rest had to be false because I did a good job of writing my conditions, it would still have to go and it would have to take time to check this, find out that it's false, 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 check this, find out that it's false. It takes time, it's not as optimum. So the better that you can design your code, the better that you can write it, the better the code will end up. Now I wrote one more that I want to show. This one I start off and I started writing some comments in here. This one is going to be give begin starting. I don't like to be too formal here. Give starting value. All right. So I get a byte of space and I set it apart and call it count. I have not saved anything in it yet, but because I declared it out here, it is global. That means I can change it anywhere else, and that change will be stored globally. So in the setup, I come in here, I start my serial connection, just in case I decide to print something, which I will in this one. And in this setup, I set count as 0. I can do that because it knows what count is, because count was global. Since count is global, even if I change something locally, if it's stored globally, that change will remain changed globally. So when I come down to here into the loop, you'll see I have some if statements. If my variable count equals 0, which it does the very first time, it's going to print count equals, it will tell me what it does equal, and then it will print first if statement. That way I know, hey, it's in this first if statement. First if statement. All right, then I come down here, and if it is less than 10, it comes into the second if statement. And it kind of prints the same thing out, except for it just says it's in the second. And I do the same thing here for the third if statement. And I'm going to do this same thing here for this if statement, my fourth. All right. Now, how is count going to change? You say you're going to say, how's it ever not going to turn into anything besides that? What we can do is you can come down here and at the very end, I do a count plus plus. That's going to increment it every time. So if it starts out at 0, then it'll become 1, and then 2, then 3, then 4, then 5. And I put a delay in here, and this delay is just because I want to be able to read what's happening. I'm going to even slow it down a little bit more for this first time. And I'm going to go ahead and upload it. We're going to see what happens. And what it's going to do is it's going to count. It's going to come into here, we know that. Eventually it's going to turn into a 1, which means it should be getting into this one. Eventually it'll get up to above 9 or 10, which means it should be getting to this one until it reaches 20. So let's go ahead and see what happens. So first if statement, second if, wait a second, what's happening here? So if we look at it, some weird stuff's happening. I'm going to stop auto-scrolling for now because I want to look at this. It went into the first if statement. It also went into the second while the variable equaled 0. It went into the third one while it equaled 0. It went into the fourth one while it equaled 0. That's because I didn't say it had to be, in this case, if count equaled 0, go into it. That happened. Right? That's right here. But count still equals 0, and this is true. Which means it's going to jump in here even when count equals 0 and to do this. Count equals 0, this is still true. It's going to jump into here again, and it will jump into here again, all while count equals 0. When count equals 1, you'll see that it skipped the first if statement. The reason for that is, well, this one's definitely false at that point. But these three are all true still. And it's going to do that until it reaches 9. It's going to run 3 of them at 9. When it gets to 10, it's only going to do 2 of them. Because at that point, only 2 are true. Then we're going to go to 20, and by the time we get to 20, there's only 1 that's true, and it probably hasn't counted all the way through yet because we're moving kind of slow. But what should happen, and I'm going to go ahead and do this, I'm going to change the delay back to 100. What it'll do is, because again count is a byte, when it loops around, it should loop around back to 0 once it reaches the maximum. And that's because that's what a byte does. It can't store anything bigger than 255, which means once it does that, it should jump all the way around. So here we go. There we go. See? 255. Then it starts back at 0, and it's just going to keep looping around. Let's fix this problem by adding some else's. If I want this to only run if the previous thing is false, I'm going to write else if. If I can spell, there we go. Else if. So true that if count equals 0, this is true. This condition definitely is true, but the else if says don't run this scope though unless this one was false. If count equals 0 or 5 or anything underneath 20, this is true. But what's going to happen is, even though this is true, this entire else if will get ignored if either one of these above it were true. Same thing's going to happen here, except for, this is my last one, that can be my default. I don't even have to worry about adding any type of condition. I'm just going to write else. If anything above it, this one, or this one, was false, either my original if statement, my else if, my other else if any of those were false, my else will run. So this one's going to be my else. This one's going to be my second else if. This one's going to be my first else if. Now it'll run much more efficiently, and it'll run the way that I actually want it to run now. That's just old data. That's where it was at when I restarted it. So I can clear my output. I'm just going to restart this. Get nice, clear stuff. All right. So now you can see what's happening. I'm going to take the auto scroll off so we can look at it a little bit closer. When it's 0, it's in the first if statement. When it's 1, it's in the first else if statement. This one here. So this is my first if. This is my first else if. And it's in there 9 times. Then I do my next one, count, and it's in there here. And it's not hitting any of the other ones. And lastly, I have my other count, my 20. My else, I mean. It's going to go in there no matter what else happens, and when it rolls back around, it's automatically going to get kicked out of this else because one of the ones above it was true, namely my first one, first if statement. And it just starts over. So this is just organizing a little bit better. That's an overview. I showed you some codes. I showed you maybe a couple things you could do inside your codes. So as you have questions with this is at least a start to get you tinkering, understanding what's happening. Ask in class, we'll discuss it some more, but definitely practice and see what you can do on your own.